What if I told you there's a robot that can run faster than Usain Bolt and navigate through rough terrain with ease? The world of Boston Dynamics is a fascinating one where technology meets art and the impossible becomes possible. Boston Dynamic robots are not just changing the game in the field of robotics, but also revolutionizing industries such as construction, search and rescue, health, and even entertainment. Get ready to witness the future of technology as we take you on a journey with the most advanced robots on the planet. So, join us as we explore the revolutionary world of Boston Dynamics robots. Boston Dynamics is renowned for producing superb robots that improve people's lives. Boston Dynamics wants to improve people's lives by creating dynamically stable, leg-powered devices. The robot's unusual design enables them to navigate a terrain that is impassable to others and carry out automatic activities in chaotic settings. The company has created creative robots that have grown incredibly popular over time. For more than 30 years, Boston Dynamics has prioritized research and development. They have been supported for the duration of that time by extremely wealthy investors including Google, SoftBank, Hyundai, and initially the American military through DARPA funds. The results of all that study and creation are beginning to show. They are now renowned for its safety features and warehouse robots that unload stock rather than for producing spooky robots like the Big Dog or grotesque robots like Asimo. These new robots are being more widely used in industry and are much more useful. They'll soon be as common in a warehouse as a forklift. Moving on, we'll discuss the top 10 robots Boston Dynamics has created that will revolutionize society. Sit back and enjoy. Atlas is one of the most popular robots created by Boston Dynamics. It is a bipedal humanoid robot that was created by a number of tech firms and governmental organizations in 2013. Nothing short of amazing describes Atlas. It had a rocky beginning, but since then, it has advanced greatly. By adding movement data to its motion libraries, it can develop and learn, and this includes trajectory optimization into intricate processes. Atlas has the ability to continuously sense its surroundings and adapt. While Atlas is able to move, jump, and crawl like the previous Petman, the depth and control of its motion are significantly more advanced. Without a doubt, Atlas will spare lives and cut out pointless labor and stress. It will be fascinating to see Atlas develop. Over the past 10 years, it has developed from a halting, lumbering gait on a level surface to sprinting through parkour courses and flipping over balancing beams. The robot has whole-body dynamic balance and is made to work both outside and inside of structures. Atlas is hydraulically and electrically actuated, and its hardware uses 3D printing to reduce weight and size, resulting in a small robot with a big work area and a high strength-to-weight ratio. Atlas can move objects in its environment and traverse uneven terrain thanks to stereo vision, range sensing, and other sensors. Atlas also holds its balance when jolted or pushed and can get up if it tips over. No doubt, this is one incredible creation. The next one is another well-known design of Boston Dynamics. It is a quadruped robot called Spot, and it's employed in a variety of fields including oil and gas, security, search and rescue, and even construction. However, it wasn't always such a plug-and-play solution, and Boston Dynamics recruited the aid of IT service provider Rightpoint to make it relevant for all of these use cases, enhance user experience, and reach full commercial viability. Project Petman, also known as the Protection Ensemble Test Mannequin, was created in 2008 for the U.S. Army by a number of businesses and organizations, including Boston Dynamics. This device was used to test specialized gear that soldiers use to protect them against chemical assaults. Petman is made to work like a regular person. It is capable of standing, walking, crawling, and even certain calisthenics like squat thrusts. Without really placing a person in risk, these movements enable researchers to assess the protective gear in a way that would mirror an actual person. The mannequin has sensors all over it, and it can even simulate body temperature, sweat, and humidity. Big Dog is another quadrupedal creation. It's a military robot that is dynamically stable. It was created in 2005 by Boston Dynamics, NASA, and the Concord Field Station at Harvard University. The military was going to employ the Big Dog as a robotic pack mule. It was made to be both powerful and agile. Instead of wheels or tracks, the objective was to move across rocky and uneven ground on 4 legs. The engine powering the Big Dog has been converted from a go-kart engine. The hydraulic leg actuators are driven by a hydraulic pump which is powered by the engine. The Pentium 4 CPU receives data from the 50 onboard sensors and uses it to control the system. In 2015, the Big Dog project was abandoned because it was found to be far too loud for practical use. Boston Dynamics created this four-legged robot to conduct studies on quadruped locomotion. As part of a DARPA-funded program on advanced robotics, Little Dog is currently being employed at the Massachusetts Institute of Technology, Stanford, Carnegie Mellon, University of South California, University of Pennsylvania, and the Florida Institute for Human and Machine Cognition. Little Dog has 4 legs with a wide range of motion and 3 electric motors on each one. The robot is powerful enough to climb and traverse reasonably difficult terrain. A PC-level computer that handles communications, actuator control, and sensing is built within the robot. Little Dog can run continuously for 30 minutes thanks to its rechargeable lithium polymer batteries. Handle is a mobile robot that combines the effectiveness of wheels with the ability to navigate uneven terrain on its legs. It has a manipulator arm that can lift big boxes and is intended for material handling tasks. Additionally, it incorporates a swinging tail that aids with balance and dynamic movement in confined places. Boston Dynamics unveiled a new version of Handle in April 2019. The new robot can pick up heavy loads while having a small footprint, which enables it to maneuver in confined spaces. It is designed as a mobile manipulation platform for logistics applications. In a warehouse, Handle may independently put together and take apart pallets while moving boxes weighing up to 15 kilograms or 33 pounds. Its onboard vision technology locates individual boxes for grabbing and placement by following marks on the pallets. Handle employs force control to nestle each box against its neighbors as it sets the boxes on the pallet. If you're a member of the light infantry, you might have fantasized of a solution to lessen your battle load. With their invention, the Legged Squat Support System LS3, Boston Dynamics is seeking to achieve precisely that. LS3 is a rough terrain robot designed to go anywhere Marines and soldiers walk on foot by helping them carry their load. Each LS3 can carry up to 400 pounds of gear and enough fuel for a 24-hour, 20-mile mission. Because LS3 uses computer vision to automatically follow its leader, it does not require a specific driver. Additionally, it uses GPS and terrain sensing to move to predetermined areas. Stretch is the next version of Handle, a robot Boston Dynamics launched in 2017 that combines wheels and legs. Stretch is an omnidirectional movable base with 4 individually controlled wheels. This implies that the robot can be placed anywhere a pallet can fit. Stretch is able to grab items from all corners of shipping containers with its extended reach of 6.5 feet and vertical reach of 10 feet, all without knowing how the container was filled or the specific contents of the packages. Stretch has an 8-hour battery life by default, but 16-hour batteries will also be available, as well as the option to plug Stretch in for continuous power. Stretch makes use of the PIC version system, which Boston Dynamics acquired in April 2019 when it acquired Kinema Systems. PIC performs robotic depalletizing using high-resolution 2D and 3D vision as well as machine learning techniques. Stretch's capability for dealing with a variety of boxes will be one of the important factors in success. Boston Dynamics' innovative and dynamic machines have completely changed the robotics industry. These robots have captivated the attention and imagination of the entire globe, from the agility of the Spot Mini to the human-like gestures of the Atlas. It is intriguing to consider the endless possibilities and potential uses of these robots in the future as technology develops. Boston Dynamics has demonstrated that robots can not only carry out duties with precision, but also exhibit a level of elegance and fluidity never previously seen, whether it be in the fields of construction, search and rescue, or even entertainment. Overall, robots have a promising future, and we're excited to see what Boston Dynamics will produce next.